everybody. Welcome to the second keynote session of SIBGRAPI 2020. I'm Soraya Mussi from PUC-RS, and I hope you are enjoying the online SIBGRAPI. Today, it's an honor for me to present Hélio Lopes. Hélio is an associate professor in the Department of Informatics at PUC-Rio. He has a doctoral degree in mathematics, a master's degree in informatics, and a baccalaureate degree in computer engineering. His research is mainly in the fields of data science and visual computing. He likes to develop and to apply advanced mathematical and computational techniques to solve real-world problems that have engineering, scientific, and industrial relevance. In addition, he's a very active person in computer graphics community and a very dear friend. So, Hélio, you have 30 minutes for a presentation and more 15 of questions. Please be welcome.
Okay, thank you very much, Soraya. Thank you so much for this nice introduction. And also like to thank the organizing committee for this invitation to be here. I'm very proud to be as an invited speaker at SIBGRAPI this year. So I will start to share my screen. So everybody's seeing my slide? So today my talk is about from data to solution in industrial applications. The objective of my talk is to present the challenge and to challenge the status quo of visual computing, data science, and software engineering to deliver data-driven solution for digital transformation. The industry nowadays, more than ever, is very interested in making internal digital transformation. We can define digital transformation as a process in which a company investigates the use of digital technology to innovate the way of working, aiming to achieve strategic objectives. Digital transformation, in fact, has to make a change in the industry culture. Unfortunately, you can find in the literature, in real life, that to make a digital transformation is not so easy. So, in my talk, I will present 7 factors that a company should be advised to make a digital transformation with success. These factors we observe in practice from the last years that we are making in real projects with the industry, and also is also based in the literature from the ones that I'm citing here. The first factor is to define correctly the objective and its digital ambition. Distinguish an optimization of a process, making some improvements on the software, to transformation itself, where we would like to make new products, new process, and everything engaged with digital technology. The second factor is the fact that effective and integrative top management support is really critical to the success of digital transformation initiative in an industry. So it requires a transversal teams and a strong support, otherwise it will not work. The third factor is bringing the key stakeholders to the initiative, digital transformation initiative, who will know how to, because they will know how to maximize the added value in a very extreme force. Eventually, in this dynamic, it's very suitable to have also part of the users, the end users, in the discussion, because they will also bring value to this transformation. The fourth factor is the alignment of the business and development, what in software engineering area, it's called the BizDev. This is important because it allows measuring the achievement of the expected results of the digital transformation. The fifth factor is to know how to deal with the opportunities and risk innovation solution. This means that it's necessary to have a conscious adoption of the digital technology, which implies that the partnership with a computer research program like the ones that we are would be a differential. Researchers in this program constantly investigate and update themselves to the situations in which software technology really work, and they know how they can be involved. Other thing that is very important to mention is the fail fast concept, because it facilitates the process of development to save money and time if you have to withdraw the process. The sixth factor is know how to evaluate and generate results. This is the reason why to make a continuous experimentation is suitable to objectively evaluate the results. And in a qualitative way, there's acceptance of the technology created. For example, at the end, you can perform an NPS test or A/B testing or something similar to that. So it's very important to evaluate the results, because otherwise you will not follow the digital transformation to the end. Finally, it's necessary to understand the minimum value product and increment concepts. Software MVPs need to have quality, or you need to think about implementing it as a final product and sustaining the solutions through the time. So these factors we really observed in this year of 2020 in several initiatives that we have done. So what about data? When you talk about data-driven solution to digital transformation, we have to think about in its cultural change. That is, to bring data into the center of the industry basis that is made up of people, process, and technology. In other words, we have to make information as a second language in the industry itself. So that's the reason that data science is growing attention in the market. Data science wants to transform data into information, and with all the expertise of the industry, transform this information in knowledge. And what the industry itself is interested is to transform this knowledge in value. And what about the solutions? Well, we have an initiative that started in the beginning of this year of 2020. That is what we called Exacta. This Exacta initiative has as an objective to act as an excellent research and development initiative to support the digital transformation of partner companies. And the coordinators of this initiative is myself, Marcos Kalinovski from the area of software engineering, Marcos Poj from optimization and logistics, and Simone Barbosa from computer human interface and data science. Well, our initiative is to has three main steps. We are based on agile experimentation, in co-creation, and into digital transformation. And we use these concepts of continuous experimentation, bringing together BizDev and DevOps. In this year, we developed and published 2 papers about our methodology that we called the Lean R&D. The Lean R&D relies on agile and continuous software engineering principles, including establishing a strong link between business and software development through the BizDev methodologies and continuous experimentation practice. And we apply this methodology in several development for Petrobras. And in this talk, I will talk about one of them that we called Smart Tocha. Smart Tocha has an objective to make a real-time cognitive monitoring of flare in the refinery of Petrobras. Since I said, as I said, this initiative is based on a co-creation. The co-creation team is very large. So you can see here people from the refinery, people from the scientists, people from the support, and people from PUC. So we coordinate through using process development methodologies, all this team in order to make this software that we called Smart Tocha. And what I will show you next was a presentation recently done by one of the team's members, André Kuramoto, from Petrobras in this conference that I'm saying here. Well, what is a flare? Flare is something like that. It has a system in which that is used to optimize production. It's designed for operational and environment safety. Traditionally, what the flare system do is to, what the operator of the flare system do is to control the injection of steam in the torch. He has to maintain the torch in the optimized situation. If it has insufficient steam, the torch, the flare, will produce soot that is very unacceptable for the environment. And on the other hand, if you have excess of steam, you will lose money because you are losing steam in the atmosphere, which could be converted in another process to produce more fuel. So, what is in the beginning? What we observed that this control of the injection of steam was made by an operator that was looking for a camera and trying to see if it is good or if it is with excess or without steam, not optimize it. So he has to look to the steam, to the flare, and see what they have to do to inject more or to reduce the injection. So what we produce in this digital transformation solution is to use computer vision, machine learning, and an heuristic to control to observe by the camera decision, to make a decision to input in a controller that will inject steam or not in the flare. So, in terms of computer vision, we use a real-time detector of the height, of the flame height, using simple techniques of computer vision, and we use deep neural networks in order to identify in which class the flare is. If it is optimized, if it is with, if it has to inject more steam or to reduce the steam injection. And we faced several difficulties. For example, clouds with the same colors, with colors similar to the flares, the flame, rain condition, and on gray sky also that reduce the detection of the smoke. But we have with this team, and this team, as part of this team, annotated several images from the flare in several daylight situations that we faced. And we produce also data augmentation, using data augmentation techniques, another image in order to improve our results. The tested data set has an accuracy of about 8%. But when we put in practice the complete system composed by the convolutional neural network, computer vision, and heuristic, when we put this pipeline in operation, the accuracy inference is close to 100%. So here's an example where we have here the height of the flare and the situations where in green where the controller opens this to inject more steam, or close the controller in order to reduce the steam injection. So using this control, we leave the suit situation to optimize one, and then sometimes it comes to a steam excess, then he started to control again, and then get to optimize, and so on. And what is very impressive using this process that we made from lean R&D, we started this project in July 6th of 2020, and we delivered in production at September 21st of 2020. Our next step is to incorporate smart torsion in all Petrobras refinery until the end of the year, and investigate the use of infrared camera to make smart torsion work at the night period. Today, it's working in about 13 hours during the day, because the usual camera is very, how do I say, unacceptable to be controlled, to control the system, because the image can be very saturated during the night. So we have to use another type of camera in order to get success in this transformation. So using this lean R&D methodology, we also deliver 4 other products, and there's coming another one, so another 5 projects during this year. Here I will talk about other industrial application which brings the vision computing together with data science and software engineering to produce value. The first example is the one that we published this year at the International Conference on Enterprise Information System. That is what we call the global phrase string, is to annotate automatically all the soap operas and series of global, making a system that fills an ontology database based with all annotated scenes in the legacy of global soap operas and series. This paper received the Best Paper Award this year. Another example is that we bring value to the industry is the use also of visual computing techniques together with data science in software engineering to produce recommender system that has been used in global play nowadays. These recommender systems take every scene in the film, in the soap opera in the series, in order to produce an embedding which incorporates the information about the video and about the audio. And when they do that, the similarity functions, when you compare one video to the other, has increased a lot using an A/B test, the quality of the recommendation. And it's being used in practice today in the global play. So my conclusions, what I have to say is, with co-creation process and dedication, it's possible to deliver data-driven solutions that really transform. We are, for the next step, we are continually improving our process to integrate more smoothly larger teams, defining more precisely the role of each member of the co-creation team. And also, we are always thinking on how to make bridges between visual computing, data science, human-computer interface, and software engineering to solve real-world problems. So that's it. Thank you for attention. And so I'll be ready for questions. I'm not hearing you, Soraya.
Okay, now, thank you very much, Hélio. Problems of this online life. Okay, thank you so much. I'm just looking here in the WUVA and YouTube. There is no question. There are no questions yet, but I have. So, first of all, I mean, your intention to build this bridge, you showed very well, putting scientific problems and industrial problems together. So I have a question regarding disclosure agreements. So sometimes you know that when you have projects with companies, you cannot exactly say everything. So how are you dealing with that?
So that's a very good question. This is very tricky because certainly some experiments like this one is very sensitive somehow. But in this project with Petrobras, we have a type of a cooperation that using the ANP verb money. So we have to produce knowledge for inside the scientific community. So we have an agreement that if they say that it's possible for us to publish, and we publish it together with the Petrobras team. So they have also, so people from the research center of Petrobras are also interested in publishing. So we have this a very good opportunity to experiment, to produce, and to transform this several initiative of digital transformation that they are facing now.
Yeah. And for example, regarding global, how it works, recommendation system, I believe you can put a lot of secrets there about the details, information.
Yes, they command that. So
okay.
they say, because most in these two situations, they are PhD students of mine. So Rafael Pena and Felipe Pereira is PhD. They are PhD students that work. One works and other one has lived the global. So, but he could publish it. They have an authorization from the top management to publish it, that results, and because it's a part of the PhD thesis, so he could. Thanks God, we could publish it, all of these novelties that we developed together.
Great.
We discussed together. So
perfect.
Global.com is a very huge experimental set, how do I say, playground to make this recommender system in real life problem.
Yes, I know. We had project with them for 1 year. Yeah. Okay, Hélio, there are a lot of questions for you. Okay, so let's start. Gandhi Alma, it's asking about the trained data sets for this kind of industrial specific problems at Petrobras was generated as a pipeline in the process of researching or before?
During the time that I mentioned, from July to September, we have produced all these annotated data sets. So you see the large team that we are working together in a co-creation. So not all the people there, in fact, a small group of people there really program. The other are responsible for annotating, for installing the camera, for getting the camera into the system, and so on. So the guy who annotates is the guy who operates the flare every day. So every day he look for the and capture the camera and annotate. No, this is an optimized situation. This is an excess. This is in a producing suit. So they take a long time to annotate all these things in several climate situations during the daylight, because our system only works during 13 hours of the day in October is about 13 hours. Maybe in the winter is a little bit less, but it's working very well. It's working in accuracy of 100% of the time. So they are very happy. So we are now expanding this implementation to several other refineries in Brazil.
Great. A question about Luiz Henrique de Figueiredo: how hard is to transfer technology to companies instead of just providing a service?
So here this is also a very good question. Thanks, Luis, for that. It's very hard to transfer the technology, but in this situation that we are facing this year, we in doing the co-creation, this transferring has been, how do I say, very easily, has been done very easily, because people are together sitting with us every day, at least 15 minutes, in order to observe the development, and all the things that we are doing are on the cloud. So this transferring is doing during the process of development, and people from the endpoint will continue the sustainability of this development along the next years. So we deliver the product, and they will continue to sustain the problem itself in using development. The people from the refinery itself will continue the development and the upgrade of the software.
Great. Another question from Joaquim Bento: what's the importance of VR and human-computer interface in these applications? How can they be better used based on your experience?
Well, virtual reality, I did not have any experience of that. I saw several people, several applications that they are thinking about using virtual reality for safety mainly. And human-computer interface is for sure very important, because we have a group dedicated for that in our development team, supervised by Simone, for example, and we have a designer that is full 40 hours with us, that is responsible to produce all UX UI experience with the client, and the end user is part of the team during this beginning, since its beginning. So we have a design sprint, dynamics since the beginning, and we are improving the interface alongwise the project development in parallel to the machine learning development itself. Another thing that I didn't mention, we also are very worried about the update of the model, alongwise the sustainability of the project, because so our intention is that if we detect some drift in the data, we retrain automatically the model and continually try to improve the delivery automatically to the model itself. So HCI is very important. I don't know how to answer the VR question today, but maybe in the future. But I saw that several people are working with VR in safety conditions for digital transformation.
Okay. Another question by Roberto Cesar. Did you face any original mathematical or computational research opportunity regarding fundamental research in your experience?
Yes, for sure. For example, in this torch, it was very hard, a very hard task. So we developed several mechanisms that it's not only convolutional neural network. We have done some different architecture in order to really the model take care of the system, of the flame situation and the several situations that we faced along the implementation. So it's not a simple CNN classification that we are using. We have improved it a lot the state of the art in this case, for example. This is done because that's why we call it lean R&D. So we have a research group dedicated to improve the model and see the opportunities to make new research things. And that's opportunity that we negotiate with Petrobras to publish it.
How many PhD students or master students, I don't know, you have in your team? And then you have the people who are engaged specific for the projects, right? How it works?
In my group, in Exacta, we have 20 professionals, 40 hours, but with other dedicated 40 hours in CLT, and with the other labs, we have about other 40 people that making research also that is supervised by me, Kalinowski, Simone, or Poggi, that also makes research on these applications, not exactly working in this methodology for Exacta, but for other industrial application for Petrobras and other companies.
A lot of people.
A lot of people.
Okay, there is another question by José Ibson. Did you have to treat noisy data? I believe in your algorithms with computer vision. Is that? Yeah.
And the noise was, for example, the one that when you have rain situation, when we have foggy.
Yes.
Foggy is very difficult to deal with, and so in this situation, when the computer vision system is not detecting, we turn off the controller automatically, and then the operator has to take the control and make the situation to continue, the system to continue.
Okay, no more questions here from everybody. People, I don't know if you want to say something. Anyway, we are almost arriving our deadline. So, I don't know, you want to say
something? The last word that I would like to say that we faced these experiments along this year that was very untypical. So we delivered 6 products to Petrobras during in the short time, is about 4 months to each product, with this team of 20, but in the co-creation process. Then the conclusion that is what I try to say here is that if you have a process, if you have an expert in the subjects that you can deliver very in an agile way and with a very high quality.
Yeah.
So, and what I try to say is that what we experienced, what was our experience this year, that was very untypical, but it's very, how do I say, productive.
Yeah, I have a final question regarding COVID related. So you have big production this year, and is everybody working home office? So with a team of 60 people, so you have 40 plus 20. So how are you working on that?
Yeah, that's a very good question. The night is a child, as we say here in Brazil. So it's very difficult for me this year. So although we have all this success product delivered, it has been, I would like to thank all my team, and I because they dressed our blouse of Exacta and our labs, das Lab, Galgos, in order to produce these excellent products. And so I could not do everything without them. And there are so many that I cannot say everyone names here. So, but I'm sure that most of them are listening to me now.
Okay, yeah. The question is, when you compare the production, when we are going to compare the production, I don't know how, in next years, our production in COVID year and in the other years. That's a problem I have with my students too. I don't have 60, but I believe there are a lot of people, maybe in computer science domain, who are actually enjoying this life, and they can have time to produce, and they have time to be at home and do the things, I don't know, when they want, whenever they want. So maybe
they are not losing so many time.
Yeah, to go
Maybe.
and
Yeah. But it's true, but the production also, the academic production is very high this year for me too.
Yeah.
So I don't know why, but it's happening.
Great year for you, Hélio. So we are so happy for you.
Thank you very much, Sarai. Thank you very much for the invitation again, with you and Roberto. I'm very proud to be here, and I love this community. So you know that.
Yes, I know. So, okay, so thank you, Hélio, again. Thank you, everybody who are here. And I believe this is the end of this keynote session. Thank you so much. It was very, very nice, Hélio. And thank you for this first day, second day. Yesterday, I had also some activities. And this is the end of the day. Normally, in the normal life, we were planning where to have a dinner. So I hope you have a very nice dinner at your home with your family.
Thank you very much.
Okay.
Nice wine, beer.
So thank you, everybody. And that's it. Tomorrow we start at 1 p.m. with the technical sections. And that's it. Thank you, everybody. Thank you, Hélio.
Thank you very much. Cheers.
Bye-bye. Cheers.
Bye.